And a very good morning again. Thank you very much for tuning again to the streaming school. Really pleased to be joined again by Mr. Sam Winch to take us through a range of different mathematical items and considerations. As ever, we have a wonderful Nisha with us as well, who's controlling everything in the background. She is in command. So Sam, how are you, buddy? Good morning.
Good morning, guys. Yeah, really good, thank you. We've got a lot to go through today. We're working on fractions, but we're covering fractions from foundation paper right up to high paper, and I think I've got 8 things on the agenda. So 20 minutes, 8 different topics. What's that, 2.5 minutes per topic?
Wow, you're gonna let's see what you can get through, buddy. Thank you so much. The screen's all yours. Just let us know when you want us to change over.
Perfect. Yeah, thanks, guys. Okay, so as I said, we've got 8 things to go through, but we're going to start off with our recap. So Nisha, if you can share my screen, please.
Yeah. Okay.
So the recap was, of course, what we did. What day are we on now? Jeez, Wednesday. Yeah, Wednesday. Sorry, recap from Monday was ratio. We spoke about simplifying, sharing, and finding different amounts. So just a couple of examples on the screen for you. Simplify 3, 15, and 21. We're going to find the common factor with each number, and the common factor there is 3. So we divide by 3. 3 by 3 is 1, 15 divided by 3 is 5, 21 divided by 3 is 7. Grab my pointer. Then we're looking to share an amount. So we've got £56, and we want to share it in the ratio of 9 to 7. Of course, what we do first is add up all the ratios together, which gives us 16. 56 then divided by 16 gives us an amount, which we then multiply by 9 to give us £31.50, and multiply by 7 to give us £24.50. And finally, when you've been given an amount already, so it says find the smallest share, we've got the largest share, which is £57, and it's shared in the ratio of 7 to 12. So of course we divide £57 by 12, which would, I'm using my trusty calculator here, would give us £4.75, and then we're just going to multiply £4.75 by 7, which gives us £33.25. So a quick recap on ratio, and I'm going to give you a couple of questions as well on ratio. Here we've got one example here, share 64 in the ratio of 7 to 1. So we've got 64 divided by 8, which of course gives us 8, and then you're going to multiply 8 by 7, and then by 1. 8 multiplied by 7 is 56, and 8 multiplied by 1 is 8. Okay, we'll do one more example down here, number 8. It says a number was shared in the ratio of 7 to 1. The smallest share was 10.5. What was the largest share? So if 1 equates to 10.5, then of course we can then just multiply 10.5 by 7 to give us 73.5. Brilliant. So this is a real quick recap of what we did on Monday. That was ratio. And today we're going to try and fly through as many of these different topics as we can. There's one actually missing off there, which is surds. Surds and number 7, recurring decimals, would feature only on the higher paper. But we'll try and get through as much of this as we can today, and then recap it on Friday. So without further ado, we'll look at the multiplying, dividing, addition, and subtraction of fractions. So here I'll read out some example descriptions of how to do each, and then we'll go over to my visualizer and I'll give you some demonstrations. So when adding fractions, we look to make the denominators the same. So you can do this by multiplying them together. And once you've done this, then of course you just add the numerators only. The denominator always stays the same. And I'll give you a live example of that in a sec. Same with subtraction. It's the exact same process. Make the denominators the same, then of course subtract the numerators together. Multiplying, I've put simples. I like to find that this is the easiest one. You just simply multiply the numerators and then multiply the denominators. If you cancel it down and simplify it, great. Sometimes it'll ask you to do so, sometimes it won't. And then divide, you've heard of KFC, keep, flip, change, whichever way works for you. You flip the second fraction upside down, leave the first fraction as it is, and then multiply them together. So let's have a look at a couple of examples for you then. We've got this one, share my screen. We've got 7 over 16 subtract by 3 over 10, the first thing we want to do is make these to the same number. So we would have, what does 16 and 10 go into? They both go into 160 because we can multiply them together. But let me just zoom in a little bit for you there. But they can also go into 80. So we could have 80 on the bottom. And of course, whatever I've multiplied 16 by, I must do to the top number. So I've multiplied that by 5. So I'm going to turn that into 25. I've multiplied that by 8. So I'm going to turn that into 24. And then my question will have 80 as the denominator, because the denominator now stays the same. 35 minus 24, of course, gives us 11. Let's do example on division. In fact, I've got one down here. 5 over 13 stays the same. So we're now going to multiply 3 over 6. Actually, we flip the second fraction, so it's 6 over 3. 5 multiplied by 6 gives us 30. Of course, 13 multiplied by 3 gives us 39. And you'll be able to cancel that down also by dividing both numbers by 3 to give us 10 over 13. Let's have a look at one more. We will do addition. I've got one over here actually, I believe. My addition. Oh, here we go. Lovely. 6 over 14 add 2 over 11. What can 14 and 11 go into? Quite a high one this is. It would be 154. 154. And what do we multiply 14 by to get to 154? You multiplied it by 11. So therefore, 6 11s is 66. And 2 14s are 28. Add that together, that gives us a grand total of 94 over 154. And again, you can cancel that down, 47 over 77. Okay, so multiplying, we're just going to multiply the numerators together and the denominators together to give us 16 over 64. But I want to move on to the next bit, which is find an amount and increase and decrease. So in a nutshell, the way to find an amount is, using a fraction, is to simply divide the number by the denominator. So in this example here, you've got 76. You divide 76 by 19, which gives us 4. And then you multiply 4 by the numerator, 7, to give us 28. Okay, so that's how to find an amount. Now, when you increase and decrease, you can simply find the amount and then add it on to the original total. So if I was to increase 76 by 7/19, then I know that 7/19 of 76 is 28. So I just add 28 to 76, which would give me 104. If I wanted to decrease, then obviously I'm going to subtract 28 from 76 to give me 48. And that would be one way to work out increase and decrease. However, you could also use the fractions you've got. So if I wanted to increase, this would be a quicker way, and I'm going to give you a demonstration now, actually, on the worksheet. 7/19 of 76. So if I wanted to increase a number by 7/19, I could also add 7 to 19 to give me an improper fraction, and then find that amount of 76. So again, I would divide 76 by 19 to give me 4, and then times 4 by 26 to give me 92. Sorry, not 92, I've gone blank. 104. There we go, I've got there eventually. Okay, so let's look back to our screen. And we can go on to a couple of demonstrations on increase and decrease. We'll start off with the top one in the corner here. Decrease 60 by 9 over 12. Of course, we're going to divide 60 by the denominator, which gives us 5, and then multiply 5 by the numerator to give us 45. I'm just going to see if the other method works. So instead of, decrease for, so what we're looking to do now is actually you could take 9 away from 12 to give you 3 over 12, and that would be another way of finding the answer. So if we know that 9/12 of 60 is 45, then obviously if you want to decrease 60 by 45, the answer you would get would be 15. Okay. So let me give you another example here. Increase 90 by 8/9. So we're going to find 90 divided by 9, which gives us 10, and then multiply 10 by 8 to give us 80. So if we wanted to increase 90, you're going to increase it by 80, then your answer would be 170. Okay, and then we can just check our answers here by going 8 add 9 is 17. So our new fraction is 17/9. 19 divided by 9 is 10. 10 divided by 17 is 170. So there's a couple of different methods on how to increase and decrease fractions. And I want to do one final, give us 16. So we want to decrease 56 by 16, which would of course give us 40. Using a different method, 4 take away 14 is 10 over 14. So then we're going to use this fraction to decrease. So 56 divided by 14 gives 4. 4 multiplied by 10 also gives us 40. Okay, so there's two different methods on how to increase and decrease fractions. Okay, so we move on to fractional indices. This can range from a grade 5 upwards. So you might find it at the back end of a foundation paper GCSE, but of course then it can go up to grade 7, working with negative fractions as well, negative fractional indices. So a fractional indices is where the denominator of the fraction is the root of the number, and the numerator of the fraction is the power. So a couple of examples on the screen here. You've got 16 to the power of 3/2. So the first thing is we find 16 to the root of 2, which of course is 4, and then we raise 4 to the power of 3, so 4 cubed in effect, which gives us 64. Over here we've got 27 to the root of 3, or the cube root of 27, which is 3, and then multiply or raise 3 to the power of 2, or 3 squared, which gives us 9. Okay, and then you can see, same here, obviously 0.5 we know as 1/2 in terms of a fraction, so it would still be 16 to the root of 2, and then raise it to the power of 1, which means it stays as 4. The two examples at the bottom, when it's negative indices in terms of a fraction, all you have to do is the same process. So 81 to the root of 4 would give us 3. 3 cubed is 27. When it's negative, you just write it as its reciprocal. So it would be 1/27. Here you'd have 32 to the root of 5, which would give you 2. 2 to the power of 4 would give you 16. So again, because it's a negative, it becomes 1/16. And what we'll do now is flick through and see if I've got some negative indices for you guys. My lovely sheet is getting full up, which is what I like to see. So here at number 4, we've got 36 to the power of 4/2. The first thing we're going to look to do is find the square root of 36, which of course is 6. There we go, which of course equals 6. And then we've got 6 to the power of 4, which as we know it as 6 times 6 times 6 times 6, which would be 36, which would be 1,296. Okay, and one more example, if I may. The example I've got here is actually in reverse. 1,296 to the power of 1/4. Well, all we're going to do now is find the 1,296 to the root of 4, and that is of course 6. We would then raise 6 to the power of 1, which stays as it is, which is 6. Wonderful. Okay, so let's have a look at converting improper and mixed fractions. So on your screen, you've got 1 2/3. All we have to do is multiply out the whole number with the denominator and then add it to the numerator. So here, 1 is our whole number. The denominator is 3. So if we multiply them together, of course, 1 times 3 is 3. Add that to the numerator, which gives us 5. So the answer to the top one would be 5 over 3. The denominator stays as it is. Same process here. So you've got 2 as the whole number, multiplied by the denominator to make 4, add it to the numerator to make 5, and then of course you've got the answer of 5 over 2. With an improper fraction, turn it into a mixed number. You find out how many times the denominator goes into the numerator. So how many 3s are in 11? Well, of course, 3, 6, 9. So the answer will be 3. And then there'll be 2 remainders. So 3, 6, 9. How do I get from 9 to 11? You add 2. So the answer here will be 3 whole ones and 2 over 3. And here's one more demonstration. 19 over 10. That would give you 1 whole one, excuse me, and 9 over 10. Okay. Let me just see if I've got a couple of examples. I believe I have. Share my screen, and I'm just going to zoom out a little bit here for you. So we've got the first one, nice and easy. I want to turn 1/2 to an improper fraction. So remember, an improper fraction, of course, is where the top number is higher than the bottom number. The numerator is higher than the denominator. So 1 times 2, of course, gives us 2. Add that to the top number. The numerator becomes 3, and the denominator stays the same. Again, turn this to an improper fraction. 5 times 13, it gives us 65. Add 7 gives us 72. And 72 over 13 is an improper fraction. To convert it into a mixed number, how many times does 22 go to 25? Of course, the answer is 1, with 3 remainder. And then you've got your answer is 3 over 22. Okay, good. Improper fractions and mixed fractions. Now, looking at equivalent fractions and 2 does go into 6, but 2 doesn't go into 9. However, 3 does go into 6, and 3 also goes into 9. So I can divide both the numerator and the denominator by 3 to give us 2 over 3. So that would be in the simplest form. And also 2 over 3 is an equivalent fraction, 6 over 9. 8 over 20, you could simplify to 4 over 10. And 4 over 10 is equivalent to 8 over 20. But in its simplest form, you'd write it as 2 over 5. The highest common factor of 8 and 20 is 4. So if I divide both 8 and 20 by 4, then straight away you get your simplest, smallest fraction in simplest form. Okay, simplify. Let's have a look at some examples here then. We've got one that we've already done, nice and easy. The highest common factor is 2, so we divide them both by 2. The highest common factor would be 7, which would give us an answer of 8 over 11. Okay, brilliant. Let's go back to my PowerPoint, and we're moving on rapidly to converting fractions. That's to a fraction and from a fraction. The first one, if we're looking to convert a fraction into a percentage, all we have to do is turn the fraction to a decimal and then multiply by 100. So this is where your calculator can come in really handy. If you had, 7 over 10, of course, the line in the middle of a fraction means divide. So we do 7 divided by 10 and then multiply it by 100. When it's converted to a decimal, if you get the 100 part, you just divide the numerator by the denominator. So divide top by bottom. If you're diverting from a fraction, then you're looking to put the percentage as the numerator. So if you've got a fraction that says 37 over 100, well then that's, because it's over 100 already, then it's 37%. And if you're converting from a fraction to a decimal, put the decimal as the numerator with 100 as the denominator. And I may have a couple of examples. Yes, a couple of examples here for you on the screen. I think we're on task 6, so we're not doing too bad. We've got a minute left. So let's see if we can finish this last little part. Half as a percentage, well, obviously we know that's 50% anyway. 1 divided by 2 is 0.5. And then if you times it by 100, you'd get your percentage. So you can follow the same pattern here. 13 divided by 20, of course, gives us a number that I'm just using my calculator. I'm cheating. Oh, of course. Yeah, it gives us 0.65. And if you multiply that by 100, that'll give you the 65%. Okay. 3 over 10 as a decimal. Well, if we divide 3 by 10, of course, we get 0.3. Now, that is 6 of the 8 topics. So, Nish, if I could come back onto the screen, please.
All right. Cool.
So that is 6 of the 8. We didn't do too bad. I think that means I spent about 3 minutes as opposed to 2.5 minutes. Sorry about that. We've got recurring fractions and surds to complete on Friday. Those 2 topics will be featured on a higher paper, so that gives us a bit more time to actually go into the nitty-gritty of how they work. Other than that, I hope you enjoyed today's lesson, and I'll see you on Friday for some more fractions and inequalities.
Thanks.
Cheers, guys.
Thanks so much, somebody. What are you up to for the rest of the day? It was a bike ride. I think you predicted a bike ride previously. Nish, am I right in that?
Yeah.
It was bike ride day?
Yeah. I'm going for a bike ride. However, the run yesterday, 10K in 52 minutes. So it's not, I don't know, I'll put it out there for anyone to beat my score. They can
did 51, didn't we?
message in and let me know how they get on.
51. You did 50. So give us some real numbers, Sam. Thank you so much, buddy. Have a great afternoon.
Cheers, guys.
Really
you too. Take care. Have a good one.
Thanks, buddy. Bye.
Bye.
And Nish, it will be all to you to lead us out super kindly.
All right, cool. Here is the optional task for Maths GCSE. Parents and students get involved. It is a link to a worksheet. Help sync up as well. And there are about 20 questions on here. I think there are 20. All about what was happening today in today's session. All the videos will be up on YouTube and on Facebook, and the links to resources and tasks will be on them as well. Up next, we have drama.
Oh, brilliant! Yes, that's the lesson that I don't know. I know the least about. Put it that way. Not to say I know anything about maths either, Sam, but maybe finances, but not maths. But yeah, thank you both so much for your ongoing help. And I think one of the key things to remember now is, now that we're lucky enough to have a few thousand people tapping in, it's all just, again, it's wonderful to see like teachers like yourself, Sam, coming together to actually help more and more people share their educational knowledge and get some of what they know out there.
Yeah, cheers, guys. And I tell you what, I'm enjoying it more and more every day. It gets a little bit easier, I guess.
Yeah, perfect, buddy. Thank you so much.
All right, have a good day.